All right. Hi, class. So we just want to continue with solving these trig ratio problems because I know they're difficult until you've done a whole bunch of them. So I just want to walk you through this set of trig problems here in positive physics. All right, so the last problem we did involved where they gave us just the vertical velocity and we had to find the other velocity. They gave us the vertical velocity and an angle and we had to find the other velocities. So now let's just look at the next problem that they give us. All right, so it says a cannonball is launched diagonally with a horizontal speed. Okay, so they're giving us a horizontal speed of 35 meters per second. And so we just plug that in here as our horizontal velocity. And an initial vertical velocity of 43 meters per second. So we just plug that in here, 43 meters per second. And that's easy. It says label the sides of a triangle and find the unknowns. Okay, so what do we have here? We've got a horizontal of 35 and a vertical of 43, 43. Okay, and so what don't we know? We don't know the hypotenuse. Okay, and so the cannonball is in reality launched in this direction. Okay, and we also don't know the angle above the horizontal that the cannonball was launched. So we don't know this angle either. Okay, so the ball's coming out, right? And they told us the opposite side is 43 meters per second, the adjacent side is 35 meters per second, the horizontal velocity and the vertical velocity, which is all we really need to know to solve our problems, but they're nevertheless asking us, well, what is this launch angle and what is this initial velocity that the cannonball came out of the cannon with? All right, well, there's a few ways to solve these, but probably the easiest way, and hopefully you remember this, but whenever you have a right triangle, if you know two sides, you can find the third side by using Pythagorean theorem. Right? A squared plus b squared equals c squared. Okay, so leg squared plus leg squared equals hypotenuse squared. So let's keep it simple. Let's just do that. So a squared plus b squared equals c squared. So we have 35 squared plus 43 squared equals hypotenuse squared. Okay, so basically we need to figure out, and we'll just take the square root of both sides. So we'll have the square root of 35 squared plus 43 squared will be our hypotenuse. All right, so let's do that. 35 squared plus 43 squared. Okay. So now we need to go to our calculator, which is here. So square root of 35 squared plus 43 squared, okay, and 55.4. All right, so we come back to here, and this is 35 and 43. Did I get the numbers right? 35 and 43, that's right, 55.4. Okay, so this is 55.4 is our hypotenuse. So we know the velocity coming out of the cannon is 55.4 meters per second just by Pythagorean theorem. So our initial velocity is 55.4 meters per second. All right, now this one is something we haven't really done yet, which is what angle is the cannonball coming at it? I know all three sides of the triangle. How do I figure out an angle? Well, we can basically use the inverse relationships. Okay, so the ordinary function, the sine, if we plug in an angle, it gives us this ratio. It gives us the opposite over the hypotenuse. It tells us basically what percentage is the opposite side of the hypotenuse. Okay, so if we have sine of 30, it means the opposite side, sine of 30 is 1/2, for example. It means the opposite side of the triangle is 1/2 of the hypotenuse. Okay, so we plug in the angle, we get the ratio. Well, we can do the opposite process, right? So here it says the sine function takes in the angle and gives you back the ratio. Well, you can do the reverse process, and you can say the inverse sine function does just the opposite process. If you give it the ratio, it takes in the ratio, it will give you back the angle. Okay, so we can use these inverse functions to put in a ratio in and get the angle back. And it says the cosine and tangent follow a similar idea. So we have inverse sine, inverse cosine, and inverse tangent functions that we can use. So let's just demonstrate that. So in this case, we know the opposite side that was given to us, and we know the adjacent side that was given to us in the beginning. So let's just use tangent, because tangent uses those angles, right? So tangent of the angle is going to be equal to the opposite over the adjacent. So the tangent of our angle will be the opposite, which is 43 over 35. Okay, so that's our ratio. So now what we want to do is say, well, if I put this ratio into the inverse tan function, so basically I take the inverse of 43 over 35, it will give me back the angle. Okay, so I can put an angle into my computer and it will give me the ratio, or I can put the ratio in using the inverse function and it will give me the angle. So let's demonstrate that. 43 over 35 inverse tan. Okay, so we come to our computer calculator, it says inverse. Okay, so we want to use this inverse function this time. Inverse, and you can see how tan all of a sudden got this little -1 up here and the little -1 up here, a little -1 up here, right? Okay, so we've got, these are just our basic sine, cosine, and tangent. If I click this, now all of a sudden I get inverse sine, inverse cosine, inverse tan. So we want to use inverse tan, which is up here as arctangent. And again, let me just verify what my ratio was. The ratio was 43 over 35. Okay, so we're going to plug in 43 over 35. Okay, again, I'm making sure I'm in degrees mode, which I am. And I get 50.856 degrees. So maybe we call that 50.9 degrees. So I come back here and I say, what is my angle? My angle is 50.9 degrees. And voila, we've answered the question. What angle is this? What is this angle? This is 50.9 degrees above horizontal. All right, so this becomes 50.9 degrees. All right, let's do one more. Next problem. It says cannonball is launched diagonally with an initial horizontal velocity of 32. So horizontal velocity, that's this side of the triangle, the horizontal side, 32 meters per second. Okay, so we can plug that in right off the bat, 32 meters per second. Label the hypotenuse. Well, this side is the hypotenuse. The opposite, this side, which is our vertical velocity, would be the opposite side. And this is our adjacent side. Determine all the unknowns. Okay, well, so which trig ratio, let's find the hypotenuse first. So which trig ratio involves adjacent and hypotenuse? Well, we've got sol, sine is opposite over hypotenuse. So cosine is adjacent over hypotenuse. Toa, tangent is opposite over adjacent. All right, well, we want to use the ratio, since we already have the adjacent and we want to find the hypotenuse, we want the trig ratio that involves adjacent and hypotenuse. So we're going to use cosine. So cosine of the angle is adjacent over hypotenuse. So in our case, we do have the angle, cos 27. And we have the adjacent side, which is 32. So we're trying to find the hypotenuse, which is the initial velocity vector. All right, so I'd like to just look at the functions themselves. So cos 27 is 0.89. Okay, so what that tells me is this is 0.89. This cosine function is 0.89. What that tells me is the adjacent side is 89% of the hypotenuse. So this is 89% of the hypotenuse. So the hypotenuse is a little bit bigger, right? This is only 89% of the hypotenuse, but not that much bigger, right? So I wouldn't expect a number that's dramatically bigger here for the hypotenuse. A little bit bigger, maybe 33, something of that nature, but not, well, maybe more like 35, but not tremendously bigger. Okay, it should be about 10% bigger. So maybe about 35 or so. But anyway, so we have our simple problem here. Now we just cross multiply. 0.89h equals 32. Divide both sides by 0.89. And I get my answer. So 32 divided by 0.89. Let's do that. So here's this. So we say 32 divided by my previous answer is 35.9. Okay, so back here, so my hypotenuse is therefore 35.9 meters per second. Okay, so my initial velocity is 35.9 meters per second. All right, so we solved that one. Now we also, that's this, the hypotenuse is 35.9 meters per second. Okay. And we also want to find this opposite side, which is the portion of the velocity that is the vertical velocity. Okay, so this is the opposite side. And let's just use, we now know the hypotenuse. So let's just use opposite hypotenuse, which is sine, right? Opposite hypotenuse is sine. So let's say sine of our angle is the opposite over the hypotenuse. The sine of 27 degrees is equal to the opposite side over the hypotenuse, which is 35.9 meters per second. Okay, again, we just cross multiply, so we get 35.9 times sine of 27 degrees equals the opposite side. So it's opposite side. All right, and then we just plug that in, 35.9 sine 27. So we go to our calculator, 35.9 sine 27 degrees, 16.3. And back here, and this is 16.3 meters per second is our opposite side, which is the vertical velocity. Okay, so our vertical velocity is 16.3 meters per second. Vertical velocity is 16.3 meters per second. All right, and see something. I think we can do one more. All right, maybe we'll do two quick ones. All right, the cannonball is launched diagonally with an initial horizontal speed of 45. So they give us the horizontal component of the velocity, so it's 45 meters per second. And an initial vertical of 22, so they gave us the upward velocity. Okay, so we have 45 meters per second sideways velocity, 45, and 22 meters per second of upward velocity, so relatively short vector. So our initial velocity is something like that. And it asks us to find it. And again, in this case, the easiest thing, in my opinion, is Pythagorean theorem. So just a squared plus b squared equals c squared. When you know two sides of a triangle, right triangle, and you want to know the third. So do 45 squared plus 22 squared equals c squared. So C is just going to be the square root of this. 45 squared plus 22 squared equals C. So let's do that. 45 squared plus 22 squared. Okay, so we're going to say we want the square root of 45 squared plus 22 squared. And that's square root symbol in front of that. 50.09. Probably round that to 50.1. So we would say our hypotenuse is, our initial velocity is 50.1 meters per second. 50.1 is C. 50.1 meters per second is our initial velocity. All right, and then again, now it's asking for angle. Again, it gave us the opposite and the adjacent to this angle. So let's just use opposite and adjacent, which is tangent. So we'd say tangent of an angle is the opposite over the adjacent. And in our case, the opposite is the vertical, which is 22 meters per second, and the adjacent is 45 meters per second, the horizontal. And so to find the angle, we take the inverse of the ratio, and that will give us the angle. So inverse tan 22 over 45. So we say inverse tan 22 over 45. Enter is 26.05 degrees. Okay, so then we come back to over here, 26.05 degrees. So this is 26.05 degrees, which probably could be rounded to just plain old 26 degrees. And we're done. All right. And last but not least, a cannonball is launched with an initial speed of 23 meters per second. So that's the vector here. So that's our initial velocity, 23 meters per second. And determine everything else. Okay. Well, this is obviously the adjacent side, and this would be the opposite side. This would be the vertical velocity. But they didn't give us an angle. So if they gave us an angle, we could figure out these other two sides. Or if they gave us one of the other two sides, we could use Pythagorean theorem to find the other side and then find the angle. But if they only give us one piece of information, which is not enough to really solve this problem, so we're simply going to say